afternoon, and thank you for joining us for this installment of the Exploring Sustainable Seafood virtual panel series. My name is Kim Thompson. I'm the director of the Aquarium in the Pacific's Seafood for the Future program. Much of the discussion about sustainable seafood and marine aquaculture focuses on the risks to and impacts to society and the environment. Most of us are familiar with concerns about feeding wild fish to farmed fish and escapes, for example. And while we've heard that solutions are underway to address these issues, it's not always clear what these solutions are and how exactly we're going to be addressing these issues. Today, we're going to be hearing from experts who are designing and innovating solutions that are helping farmers produce more healthy seafood while reducing the risk to the environment and helping businesses do what they do, which is to make a profit. I'm pleased to welcome our panelists, Chris Oakes from NovoNutrients, Tyler Sclodnick from Innovasea, and Dave Fredriksson from the U.S. Naval Academy. You can find their bios and additional information from this and other panels in this series at aquariumpacific.org. Now let's dive in and get to know a little bit about our panelists. Tyler, we're going to start with you. Tell us a little bit about the work that you do, and is what you're doing now anywhere close to what you thought you were going to be doing when you first applied to college?
Thanks, Kim. As Kim mentioned, I work for Innovasea Systems. I work in the open ocean aquaculture department. So at Innovasea, we do a lot of different things, all involved with ocean sustainability. But the department that I work with looks at open ocean fish farms. So we make the pens, the mooring systems, the feeders, and pretty much anything that a farmer needs to make their farm profitable and sustainable. Now, when I started going to college, I was more interested in conservation and sustainability, and that morphed over time into this interest in aquaculture, which a lot of people think of as sort of a big business. They like to say factory farms and all these words they've read about or heard. But I see aquaculture as a conservation tool, as a means to balance the need to feed the world with the need to use our ocean resources sustainably. So I would say, yes, I am doing what I envisioned when I started my graduate degree and even undergrad, but it definitely looks a bit different.
Chris, we're going to move to you. So tell us a little bit about the work that you're doing, and is it anywhere close to what you thought you were going to be doing when you first applied to college?
Sure. Well, thanks, Kim. It's great to be here, a part of the panel. Well, I set out in college to become a marine biologist, and I was focused on nearshore fishes, studying nearshore fish assemblages and their relationship to aquaculture production facilities. Today at NovoNutrients, we're working to build a circular food system focused on really saving billions of fish by taking the wild-caught fish out of the aquaculture system. So I scuba dive a lot less than I would have thought, but I love being a part of the conservation effort around making aquaculture more sustainable through the food system.
Great. And Dave, how about you? Can you tell us a little bit about the work that you're doing? And is it anywhere close to what 18-year-old Dave thought he was going to be doing when he first applied to college?
18-year-old Dave, that was a long time ago. Yes, thank you so much, Kim, and thank you for asking us to be on this panel today. My name is David Fredriksson. I'm a professor of ocean engineering at the Naval Academy. I'm also the director of ocean engineering at the Naval Academy. When I was actually in 6th grade, I knew I wanted to go into marine or ocean science. I knew it. And going into college, I went to a maritime academy, and so immediately I went out to sea. And then my advanced degrees are from the University of New Hampshire in ocean engineering, and my PhD was working with offshore aquaculture systems. And so, yes, this is exactly what I wanted to do. And I'm very happy to be doing this every day of my life.
Great, thank you. Yeah, and it's been interesting throughout this series because we've seen, I think, a lot of people go into marine biology thinking, oceanography, biology, but it's been great to see here you guys are as engineers and innovators creating the technology. We've heard from economists, we've heard from social scientists. So it's great to hear the diversity of options out there for people who want to get engaged in marine conservation. So before we dive deeper into our conversation about the great innovations and technologies that you guys are working on, I first want to learn a little bit more about your process, because this is so interesting, right? I don't think a lot of people think about the innovation and engineering side of this piece of ocean conservation. So now I really want to start to really dive in and learn about the specific projects that you guys are working on. And Chris, we're going to stick with you on this because you started this conversation about what you're doing with the CO2, which is very intriguing. And so, one of the topics that a lot of people are familiar with, if they know little to nothing else about marine aquaculture, they're probably familiar with the issue of feeding wild fish to farmed fish. And this is a really big, complex issue for which there are a lot of organizations and entities involved. And while there's been a lot of momentum and progress, we still don't have that silver bullet quite. But there are a lot of you working toward that silver buckshot or those pieces of the solution. And NovoNutrients is one of them. So can you give us kind of a high-level Cliff's Notes version of what you guys are doing to try to solve this important piece of the puzzle?
Sure, I'll call it the silver side bullet. We'll go with that. And so, as I mentioned a moment ago, we've got a technology that allows us to take industrial emissions, greenhouse gas emissions, and through a process called gas fermentation. So we ferment beer, we ferment wine. This is a way to ferment this input. We grow microbes, and those microbes themselves become a very useful product. They're very high in protein, and they have other vitamins and minerals that are very useful for fish. And the amino acid profile of those microbes actually resembles that of wild-caught ground-up fish, called fish meal. And so we take these CO2 plus hydrogen inputs, we ferment them all, and then the output is a product that's useful for aquaculture, and eventually other compound animal feeds and potentially human food and other applications. So we're trying to really bring circularity to the 38 billion tons of industrial emissions that are put out every year, and turn some of those emissions into something useful.
So it sounds like you're attacking kind of two really major problems, right? So you're attacking first that issue of wild fish to feed farm fish, but then you're also looking at the 800-pound gorilla in the room, which is climate change. And so you're able to find creative ways to help mitigate some of the CO2 issues that we're having.
Precisely.
Wonderful. So Dave, there's another issue that people may be familiar with, and that is the issue of wildlife potentially becoming entangled in gear. We're seeing this in wild capture fisheries, and those concerns are trickling down to aquaculture. So we're seeing this in the New England lobster fisheries. We're seeing this on the West Coast with crab fisheries. And naturally with aquaculture, it also has lines in the water. And so this is a legitimate concern. So you and your team are starting to work out some solutions that may help to reduce the risk to wildlife on the farms. Can you tell us a little bit about the work that you're doing?
Yes, Kim, I am working on some really cool projects with respect to addressing the entanglement problem. Probably the biggest project I'm working on right now is being headed by NOAA. And there's a team that NOAA has organized where we're trying to develop computer model simulations that can actually model the whale swimming in the water and then interacting with the fishing gear or the aquaculture gear. So when you're doing this type of modeling, and it's fun if you're playing it as a game controller, but it has to have the physics in it, and it has to have the representation of the gear and that really complex interaction. It has to have that math in the programming. And then once you develop that modeling tool, you need to validate it. And so I'm working on tank tests where I'm actually taking models of whales that look a little bit like submarines, because I am at the Naval Academy. And I'm taking these things and I'm ramming them into modified gear as if it's a whale becoming entangled. And then the third part of it, and I talk about the portfolio approach and the multiple tools in your toolbox, and that is the development of instrumentation. And so we are on the verge of starting a project where we want to develop sensors that can actually go on the gear, that could sense when this interaction occurs and either do something about it in situ or communicate back to an operator that something's going on. And it has to be made in an economic way. And so it's a really fascinating group of people to work with. We're working with Protected Resource Division folks in NOAA, a lot of whale experts. I'm working with GIS people and other ocean engineers, and it's a fabulous group to work with.
So it sounds like this is a process. So this process of designing and building solutions, in addition to being playtime, the video games and the tanks, it's also a process of, in addition to you guys building the solutions, first you need that baseline knowledge and you need to understand all of these different variables so that then you can design those effective solutions.
Absolutely. We need the baseline data sets to understand really what's happening, and we don't have that fully explained yet.
So we need to invest in the science.
Yes, and the engineers.
And the engineer, and the social scientists, and the economists. There's a plug for all of our friends.
Absolutely.
So, Tyler, I want to turn to you. And before we got into this, we were talking with Dave about his sensors to help reduce the risk to wildlife. So, Innovasea has some sensors of its own. So can you tell us how you are using this technology to help farmers reduce their ecological footprint while also making a profit?
The sensors themselves are not novel or unique in and of themselves, but what we do is we add an acoustic communication network such that you can get live data on the cloud. And that allows the operator to respond to changes in the data in real time. So a perfect example of this is oxygen, which of course fish are very dependent on. And if there's variation in your dissolved oxygen level, if it goes below a certain threshold, you need to know about that so you can respond to it quite quickly. So operators can get a live alert, a text message or an email or something like that, and they can respond right away. And where we're going next is automating responses to those data streams. So for example, with oxygen, you can have an oxygen diffuser equipped on your pen, and it doesn't run 24/7. You don't need it unless there's an event going on. And so you can have these live data streams automate the on-off controls of this air diffuser. And this can potentially save a whole pen or a whole crop of fish, which is of course a big win for both the farm and the sustainability of the industry, because you've already invested resources, feed ingredients and fuel and all that into these fish. So it's a big win for the whole industry. And as we're adding more and more sensors that have this live data streaming capability, we're creating this whole data pool, which we can do more advanced analytics on. So we're trying to transition the aquaculture industry more towards precision agriculture. So if you're familiar with that industry, they use a lot of remote sensors and satellites to do a lot of analysis, and they're getting very, very precise with their operations and gaining all these small percentage points of efficiency, which end up to a big benefit to both the farmers and the community. So when we have all these data streams on temperature, currents, oxygen, chlorophyll, all of these are coming in, then we can fine tune the amount of feed that you give to the fish, the frequency that you might bathe them for parasites, how often you're going to clean the pen for biofouling, and all these operations that have a cost, both an economic cost to the farm and often an ecological cost. We can refine that and make the decision-making process much more precise. And so that's a big one for the industry, as well as for the consumers, because you can get a lower price, and for the ecological impact.
So it sounds like these sensors are really helping farmers to be more proactive in being able to manage both from in reducing environmental risk, but then also to help improve their profit. And then in theory, then could this also help animal welfare? So if you have those sensors in to ensure that the environment is ideal for these animals, is that component also a benefit?
Absolutely. Animal welfare is always at the forefront of everybody's minds, both because most aquaculturists are essentially ocean people. They're scuba divers, they're environmentalists. They all want what's best for the fish. And also, a healthy fish, a comfortable fish, a low stress fish performs a lot better. They have a lower mortality rate. They convert feed into biomass much more efficiently. So that's something that everybody is aligned on. Everybody wants to have a better environment for the fish to live in.
So Dave and Tyler, you guys also both have some experience with cage design. So some people may be familiar with the really beautiful designs we've seen of the spherical patterns underwater. We've also seen kind of the spaceship looking designs that are submerged in the water. But while they're beautiful, they also do actually serve a purpose. They are designed strategically for specific reasons. So Tyler, we're going to start with you on this one. Can you tell us a little bit about why the design of the cage matters and kind of what goes into the process of your thinking about these designs when you create them?
Yes. The main driver is that the ocean is a very dynamic environment and the world is a very large place. And so we would like to utilize environments that have very different oceanographic conditions. And so we need solutions that will address each of those different set of circumstances. So the industry has been very successful. And when I say the industry, I'm referring to mariculture, ocean farming. It's been very successful in a lot of areas. We can look at Norway or Chile, where they have very mature industries that are doing great with an HDPE, a plastic ring floating pen. And in those areas, you don't need to get more sophisticated than that. They're successful, it's working. But when we look at expanding into new regions, for example, Latin America, Southeast Asia, even USA, on both coasts, they're often very exposed shorelines, and they have hurricanes, typhoons, these storm events. And what has been successful in those protected areas will not be protected in these new areas where we want to expand. So when you mention these big spherical or spaceship-shaped pens, like you point out, they're not designed by artists. They look very cool and that's awesome, but they're designed to be functional. And there's sort of two major drivers of that. The first one is how do we deal with these rough environments, storms, intense wave energy. And one of the best ways to deal with that is to use a submerged pen. So the pen can entirely go under the water, and then the wave energy will dissipate as you get deeper and deeper. So instead of making a really big, tough, take that energy and survive type pen, you can make a lower cost pen that just goes below that surface energy, and it can survive there because it doesn't experience the energy as intensely as it would at the surface. So that's why the spaceship shape or the spherical shape, it's because they're submersible pens, and that's a much more appropriate solution for a lot of the areas where we're trying to expand into. The other big benefit is when you look at these higher energy areas that often have stronger waves, they also usually have stronger currents, and that gives you a much higher ability to disperse and assimilate nutrients. So we were discussing earlier that these outputs, these effluents from the farm are actually nutrients, and they only become problematic when they reach these really high densities or really critical levels. And so when you utilize a higher energy environment, you have a much better ability to disperse those nutrients. And so from the farm's perspective, you can stock your pen more densely without exceeding these thresholds that might become detrimental to the ecosystem. And so your investment in capital gets utilized more efficiently because you can put more fish in every unit volume of pen. So those are some of the big drivers that we look at. How do we utilize or how do we design a system that will succeed in new environments? And how do we take the benefits that those environments offer and capture that in the bottom line for a farm?
So Dave, this sounds like something you might have experimented in your lab. So as Tyler was mentioning, going below the high energy surface, I'm guessing you've had something to do with some of this research.
Everything that Tyler talked about is like what he says is spot on. And putting gear in the open ocean as opposed to bays and fjords where the salmon industry is located requires a heavy duty engineered approach. And when you do a heavy duty engineer approach, you always run up against the roadblock of economics. And so that is what I work on. I work on developing engineering techniques, computer models that represent the really funky dynamics associated with the open ocean. So you have these waves going by, you have currents, and you have the interaction between the two of them. And then you have the structure itself. So to design not only the cage, but the mooring that holds it in place, you need to have numerical modeling capabilities that are validated so you feel confident with the results coming out of those equations. And I have spent most of my career validating these modeling tools so we don't have to have a Roman engineered approach where we over and over design it because of the economics. So it's a very key component with what I do. And it's not just with finfish either. There are other aquaculture products like shellfish, oysters, and mussels. Those type of structures will interact with the ocean differently. So the hydrodynamics are different with those structures. Or what about kelp and macroalgae? So those type of structures are also totally different. And what are the hydrodynamic properties associated with those entities? All these entities move really weird. They make weird shapes and have weird deformations in the oceanic environment. And so we really need to understand that process to validate our computer models.
So it sounds like, you know, the gear design and then even the materials that you decide to use, they're great in helping to minimize some of these impacts and maybe some of these hindrances to, you know, healthy animals and profit, but they're not in themselves a magic bullet, right? It sounds like the farmer also has some responsibility for upkeep and maintenance to make sure that these systems are working as they should.
It's never going to be easy peasy running a fish farm. There's always maintenance. You always have to inspect your pens, but you can reduce a lot of your operational cost. You can reduce the risk of entanglement for the local wildlife, and you can reduce the potential for impacts on the ecosystem. And these products are addressing that. And also, like you said, they address a set of problems that some farms have and other farms don't have. So there's no product that's just a win for everybody. It addresses a market niche, which is large and needs addressing, but it's only for farmers that experience these problems.
So we've learned a lot about what you guys are doing. We've learned about some of the great products that these innovations and technologies that you guys are designing, you know, what they can do to help us address some of these bigger challenges so that we can ensure that we can have farms that support healthy ecosystems and environments while also supporting healthy profits and economies. But now let's talk about some of the challenges to the technology itself. We've heard Dave mention a number of times, if it doesn't work economically, then it probably is not going to work no matter how good the design is on paper. So Chris, let's start with you. And, you know, what is it going to take for your feed to be used by aquaculture producers and fish farmers at scale? You know, what is it going to take for it to be profitable enough to make a dent in terms of conservation as you're intending it to?
So it's a good question, Kim. Scaling up is really hard. Everyone talks about the valley of death as a startup, and getting the capital to put steel in the ground is not easy. We're not a software company. We're an infrastructure company. And the scale of the problem is that about 5 million tons of forage fish are caught and ground up and fed to the farm fish and shrimp that we like to eat every year. And the aquaculture industry needs to increase their inputs to keep up with aquaculture's growth by about 8-fold over the next 10 years or so. And so we have to build really massive factories to do that. And as a business, to sell to our customers have sort of minimum quantities that they're interested in. It may be 10,000 tons, which is not a small amount. And so our approach to scaling up is to work with strategic partners on both the feed manufacturing side. We recently announced a collaboration with one of the major salmon feed producers, Sclodnick, as well as the emitters, right? We're solving an industrial emissions problem. So we're strategically partnering with major emitters. Right now, we're working with through a Chevron Technology Ventures Catalyst grant to start testing our process using Chevron's emissions from a refinery operation. And so we're going to have to think about building plants on the scale of oil refineries and cement factories and these massive scale things. And that just takes a significant amount of capital. Now, with that said, we have a strategic approach. We're to have an impact on the forage fish problem. We need to be at these very large scales. But to get there, we have to have a way to be profitable at much smaller scales, at the pilot and demonstration scale. And so I talked about our microbes becoming the product themselves. We can also engineer the microbes so that they produce very useful, high-value feed additives. Salmon are orange because they eat these carotenoid pigments, in their wild diet. We've been able to engineer our microbes to produce some of these very same carotenoid pigments. And that will allow us to start selling much smaller volumes of material using the same industrial emissions in and biomass out process in a way that will help us actually get across that valley of death as a startup in the scale-up process. Some of the external factors that could really help a company like NovoNutrients would be a carbon tax. And if there's a price on carbon, there's now a cost to the emitters so that they want to invest in solutions that offset their carbon emissions. If there's no price on carbon, you can just keep pumping it into the atmosphere and who cares? So that's something as a society, the closer we can get to that, the sooner we'll see, the sooner we can get to that, the sooner we'll start to see these carbon utilization technologies scale up. And then on the downstream side, the feed manufacturers, they know there's a raw material problem, right? We can't take more fish out of the ocean. That's maxed out. We need 8 times more, the amount of inputs than we have today. So I'm seeing a new approach by these feed manufacturers to go out and try to shepherd along the startups like NovoNutrients to really figure out how to scale up. My customers know that an offtake agreement for a startup means that I can go raise the capital to build my next plant. And so they're starting to recognize and act on that, to throw their weight around and help the startups really do the scale up that needs to take place.
So it sounds like the scale of the solution almost has to be equal to the scale of the problem, right? So you do need the infrastructure, which is going to be big. And it sounds like in order to do that, you need the capital, you need the funding, and you also need those strategic partnerships. And as you just mentioned, a part of that then is some of those, for you, the feed companies are going to be relying on your raw ingredient for their own product. So it's those strategic partnerships. And then you also mentioned diversifying your portfolio of product, which could also help.
Exactly. I think, there are a lot of ingredients that go into a compound animal food or feed. And not all of those ingredients are priced the same. And so we can start to look at our process as just a manufacturing process that can produce a variety of ingredients. And, if we're doing the business of biology, we have to find, go after the target ingredients that will allow us to have profit margins. I mean, that's the whole point of business. And so that's the beauty of using biology to make the product is biology can be engineered. And I should note that our protein product is non-GMO, it's all natural microbes. But what we've come up with is a really clever way to architect microbial communities to change the amino acid profile. So if we actually wanted to make a salmon feed, we can architect a slightly different microbial community to produce the particular amino acid profile that salmon might want. And we could do the same thing for a poultry feed or for a dairy cow feed. So we can start to change the outputs so we can start to tackle these different markets and really achieve these economies of scale that we want to achieve, to start to make the megaton dent in our emissions problem within the next decade.
So in addition to having a diverse portfolio of product, you also need to have adaptable product, being able to adapt to the markets. But ultimately what it really boils down to, what I'm hearing you saying, is that if your company can't make a profit, then no matter how good this idea is on paper, on creating this feed that can also help to address climate change, is never really going to happen unless it is profitable. So we just learned from the feed perspective and the really great work that you guys are trying to champion of kind of tackling these two really big issues of feed and climate change. But then, Tyler, so Innovasea is really interesting because, well, NovoNutrients is a startup and they're still just, getting started. And Innovasea is a business that is currently commercially operating. You already have your client base. You are selling to clients, to farms. So from that perspective, what are some of the challenges that you guys are facing in terms of providing these scalable options and products and solutions actually in practice as a full-grown business?
It's a complicated problem. Every client we work with is unique. They all have a business plan that might be 30,000 tons, or it might be just 400 tons. And they require different solutions because their capital outlay can only accept, certain size solutions. So it's easy for us to say, we'll design it bigger, we'll, aim for larger scale farms. That kind of makes the economics work in a spreadsheet, but that's not the reality of who we're dealing with all the time. There are people who do want to go big and take advantage of scale, but that doesn't make sense for everybody. So that's definitely something that we deal with and we talk about a lot. And the other sort of related issue that we deal with is just maturity of the industry. So a lot of people look to salmon as an example of how they're going to operate because that's a very mature industry. It's a very successful industry, but it's also a very mature industry, both in the nature of the species and the countries in which they operate. So if you look at an island nation in the Caribbean, you don't have the support industry, you don't have the feed ingredients or the local feed supplier. You might have to buy your feed from far away. You don't have the genetics in the local species there to get your high efficiency, high growth species going right away. And so that makes it very difficult to grow the industry, especially as we're focusing on new areas and new fish species. So there's sort of related problems and ones that there's really no easy answer for. The answer is we have to look at every situation uniquely and deal with them as they come. And as these sort of trends develop, then we can create products that will fit for this larger group of clients that we can deal with.
So, that's an interesting point about, the difference in, you have some producers who have the capacity, they have that kind of the other pieces of the business that are necessary to make it work, like the established hatcheries or feed producers. And Chris kind of brought this up before of, those strategic partnerships of, for feed, for example, if those feed producers need those raw ingredients, they're starting to help to really look at ways and solutions to make sure that Chris's business gets off the ground because they need his product. So how could we, collectively as a society, who are the players, or how can we ensure that these smaller farms that are just getting started, that don't have that infrastructure, how do we support that? How do we facilitate that and kind of bring that up so that they can become eventually commercially producing players?
It's again a complicated problem and a regional problem, and there are a lot of people starting to look at this. The first one, of course, government support and subsidies. If aquaculture were to receive the subsidies that other industries are receiving, it would change a lot of financial models in their favor. So that's a big one. The other one is there's a lot of financial instruments that people are starting to look at, addressing the specific problems that farmers often have. So as a smaller scale startup fish farm, it's very common to have issues in the second year of operation. So you've spent all your money on capital, you have all your equipment in place, you've done your first grow out, and it's a lot of money in feeding all these fish. And you probably accounted for that in your plan, but then when you have to buy feed for your second round of grow out, the reality has deviated from your plan far enough that often people have trouble. Because it's hard to forecast for a lot of problems, whether it's disease or hurricanes or any number of things. You can put contingency into a business plan, but it's hard to really account for that. And so that's often where we see a lot of farms struggling. And so we're seeing different feed companies offering loans. So they'll supply the feed and accept payment later on down the line. We're seeing similar things from other industries. And it's not the most creative solution. I was going to call it a creative solution, but it is done in other industries. But more financial support like that would be very beneficial to the farmers. And also just helping industries get off the ground. So I mentioned small island countries in the Caribbean, which I use because we get a lot of inquiries with projects of that nature. There's a lot of opportunity, both from a social perspective and also from an oceanographic perspective. And often what they lack is the financial instruments, either the capital or just the security to make that investment. So the other thing I would mention is insurance, which is again sort of a developing aspect of aquaculture, and it's something that's very rarely talked about. And of course we have aquaculture insurance. There's a lot of different products available, but it's still something that's maturing, and it's still something that's very much geared towards the large salmon players, less so than the newly developing startup. And that's because that's where the money is. And so it's hard to develop these products for the new startup, particularly because it's a data poor area. But that is something that would provide a lot of confidence to people who want to invest in a more risky project.
It sounds like what's really needed for some of these smaller startup entities, especially in some of these middle or lower income countries, might be more financial support from the government, and then also financial support from private investors in the form of loans or even insurance could help them get underway.
The capital is there in a lot of places, and either the risk is too high or just the personnel is not there. So it's both an issue of connecting capital to the people who want to do it, and also providing just a little bit of support, either reducing risk or making some incentives just to tilt those projects that people are passing on and making them look more attractive, because there's more government support, either financially or through tax breaks or whatever, would tilt a lot of projects that are sort of balancing on the edge right now.
And it sounds like some of those proactive tools that you guys have been creating with your sensors could also help to reduce some of these financial risks that you mentioned that some of them might run into in terms of kind of those unanticipated impacts, right?
Absolutely. Like I was describing, the oxygen sensors, once again, a great example. Certain farms are seeing mass mortality events because there's a low oxygen event or an algal bloom. And if you can have some confidence that you can avoid that, that's of course a big assurance to the farm, and you don't have those losses. So definitely.
So I'd like to add something that Tyler just mentioned, and that's people. I think one of the most important areas that we need to invest in, not only as a country, but as an international community, is the education of people. If we don't have the scientists, the engineers, and the ecologists, and the economists working together with suitable educational backgrounds, this is not going to happen. And so all the capital in the world is not going to make it happen if we don't have the people educated to do that. And as an educator, I personally would like to infuse energy into the younger generation and develop these new programs. I think there's a need to develop new educational programs that focus on the areas that Chris was talking about, that focus on the areas that Tyler has been talking about, and be able to provide a workforce to make this an optimized, sustainable source of food and other ocean products.
I think that's a really important point. So it's not just about the financial capital, it's about the social capital, and it's about the environmental capital, and balancing all of these key pieces. So I want to thank, so we have Dave, Chris, and Tyler. You guys have really, informed us about these amazing solutions and innovations that are underway to help ensure that we can balance both the needs and the health of society and the environment with also the profit, which is how businesses function. We need these businesses to be profitable so that they can then operate in these sustainable ways using these innovations and tools that you've created. But now I want to dive into the burning question, which is, can we leverage these technologies and solutions that you guys have been talking about to develop a marine aquaculture sector in the US that is both economically and environmentally sustainable? And do we have those technological and innovative tools to do that now? Tyler, we're going to start with you.
I would say we can, and we are. Blue ocean mariculture is operating in state waters in Hawaii. I think that's the only example of an offshore fin fish farm in United States waters. It's in state waters, but in the United States. There's other examples that are not perfect examples. The salmon industry in Washington, of course, is undergoing some upheaval right now. But there's a lot of attention. There's a lot of projects that a lot of us are working on in Southern California, in the Northeast. There's a lot of research projects going on in Florida right now. And the concern is not the technology, it's the legislation. So people are no longer concerned about whether we can do it. They believe we can do it. They're ready to put their money towards it. It's, can we get through the legislative hurdles to be allowed to do it? And it's because they're looking to nearby countries. There's fish farms in Ensenada, just a couple hundred meters. There's farms in Ensenada, Mexico, which is just a few kilometers south of the US border, that people are looking to and saying, if it works there, why not here? And they're right, it would be similar systems, it would be similar species, and it could be a replicable system. And that's true for a lot of different areas. There's a thriving industry in Canada, in similar countries in Europe, and we can borrow those systems and apply them here. And the technology portion is sound. It's ready to go. There's opportunity for improvement, but it could be done today.
And Chris, how about you? Do we have the technology and innovation to move forward with marine aquaculture in US waters now?
We do have the innovation and the motivation to make aquaculture a really successful industry in the United States. One of the challenges on the feed front is that we don't have all of the infrastructure in place in some of the best places for aquaculture. Tyler mentioned Hawaii. There's not a feed mill in Hawaii. The producers there have to import all of their feed from the mainland. And so I envision a world where we've put in some infrastructure that doesn't require acres and acres of land to grow soy, to turn into soy protein concentrate to go into the fish feed. Rather, we can use an acre to produce it using some of the industry emissions on site there. And that's what we don't have. We don't have the scaled infrastructure in all of the right places, like Hawaii. But technology and innovation and motivation, absolutely.
And Dave, how about you? Do we have the technology and innovation to farm responsibly in U.S. waters now?
We have some of it. And I think Tyler and Chris both highlighted the aspects that we still need. I love the analogy to agriculture and looking at that business as a potential model, not exactly obviously, but as a potential model. That's the level of operation we really need. And that's the level of technology we really need. I see things that Tyler was talking about with in situ instrumentation that can monitor real time what's happening. And then you need some automation that can actually do stuff on site if some bad event happens, so you can mitigate things immediately without having to send people out there. That could also be cost effective. And I see a lot of industries, I mean, look at the cell phone industry, Apple, and look at how far they've come from when I was a kid, when I had a rotary telephone, and I'm that old. And we need to have that type of perspective when we go into sustainable aquaculture food production. And we need to borrow from the design approaches where there aren't any boxes that are preventing you from going in a particular direction. And I come back to the education again. I think that concept needs to be a part of the educational process. And get the younger generation, infuse the energy in the younger generation to see this as like, we need to do this, and to come full circle, have the same passion that all of us on this interview have, and have a lifestyle where we feel like we're benefiting not just ourselves, but other people.
It's clear that there's a lot of hope that there are still some improvements that need to be made in terms of technology and innovation, but we aren't starting from scratch. There's a lot that's already been done. There's a lot that's already in practice in farms that are currently operating, including a farm here in the US and Hawaii and offshore waters. From all of you, I want to hear what the one most important thing you think needs to happen for these innovations to succeed. And Dave, I'm going to start with you on this one, because you had just mentioned that there's still ways to go in terms of innovation and technology. So if you're talking to society, if you're talking to policymakers, what is it that needs to happen to help push these innovations and technologies along?
I'm going to sound like a broken record again, and I think it's human capital. And I think it's getting more people focused on the problem and having the educational backgrounds where they have the tools to focus on the problem. And I feel strongly about that, and that's where my passion is in the education along with the technology.
And Chris, how about you? What is the one most important thing that you want to get across? What is society and policymakers, what do they need to know in order to ensure that technology and innovation is moving forward in the aquaculture sector?
Well, I'm biased. I want to create a circular economy where we're taking greenhouse gas emissions and turning it into something useful for the aquaculture industry. And as I said before, a price on carbon is something that is really going to motivate a lot of innovators that can turn that waste CO2 into useful products. So that's what I want to see.
And Tyler, you get the last word. What is your one key message to society, to policymakers, to decision makers that needs to happen to move these innovations forward?
David and Chris both gave excellent answers. I'm going to say something different. I think we need legislation in place to let people start trying. There's a lot of chicken and the egg going on. It's hard to build support industries without an industry to support. And so once it gets started, it builds organically, and it builds capacity, it leads to innovation, and it can all happen organically once the industry is allowed to start. And I see the big roadblock as legislation. That is to say, getting a permit and being able to go install infrastructure and start farming fish. So if it needs to be conservative to start, that's fine. Hopefully it's not crippling the industry. But if there's concerns about environmental impacts, we can structure the legislature to reflect that. So there's no reason why it has to be yes or no. You can say yes with these restraints and people can get started, and we'll learn and we can update the regulations. And then during that time, the industry will mature in this country. And there will be an industry for NovoNutrients to supply, and he can get rolling. And all these other startups and people who want to get rolling will have somebody to supply. There will be an industry to work with. And the innovation will happen organically from that.
So it sounds like your key messages then, your key takeaways that you want this audience to come away with, and perhaps others, is that we need a carbon tax to help with that circular economy and help NovoNutrients and others help to create economies off of capturing carbon. We need social capital. We need to invest in education and expanding the workforce, including in expanding our knowledge of these interactions that farming has with the oceans and then how we build these solutions. And then, of course, we need to look at the policy and legislative piece. We need these enabling policies that can help these farms move forward in a more efficient and economically viable way, while also then protecting the health of the environment, as well as society and the communities surrounding it. We've learned a lot about this innovation and technology, which really gives us hope for the future. So now we understand that it is possible to balance the needs of society and meeting the demands for food and nutrition in a growing population, supporting healthy planet and ecosystems, while also helping businesses be profitable, which in the end is what they are designed to do. Thank you to all of you tuning in and joining us. Once again, you can go to aquariumpacific.org to get the bios and additional resources from this and other panels in this series. Thank you so much. Now go eat some seafood. Bye.